Alright, this video is for I can graph absolute value functions. This would be for homework 9 and 10. So this is in class 9, which is 9 and 10. Absolute value is a graph that is represented by f of x equals the absolute value of x. This is the parent graph, which can also be written with a y. There is a transformation of the parent graph, which is this here. A, which is your slope, times the absolute value of x plus or minus h, absolute value plus k. Talking about this graph, the domain is always going to be all real numbers. And your range, parent graph, is going to be y is greater than or equal to 0 for the parent graph. On the transformation graph, you have y is greater than or equal to k when a is positive, and then you have y is less than or equal to k when a is negative. So with that translation, you move a figure up and down. When k is your up and down movement, it's exactly what it says. So you're going to move this graph up and down. You're going to go up if your k value is positive, and you're going to go down if your k value is negative. So with that, we now have the other type of translation that we have, which is our h value, and that is opposite what we think. It means we go left and right. If we're going to go left, our h value is positive. If we're going to go right, our h value is negative. H is opposite of what you think. K is the same. So the other thing that we have is reflections. When a parent function is multiplied by -1, the result is negative f of x, which is reflection in the x-axis. So when it's outside, it's going to be the x-axis. And when it's on the inside, when the variable is multiplied, that's in the y-axis. Dilation, shrinks or enlarges proportionally. It's stretched or compressed vertically. That is where we take the graph and we are just changing the slope or the rate of change between points. So what we have here is we have our parent graph. Okay. So with our parent graph, we have values in it. So what we're going to do is we're going to look at a transformation and identify key ideas here. So with that, you have a, which is this value right here in front. That means a is equal to the value of 1. We have our h value, which is in here. H is the value that we add or subtract to x. Nothing's being added or subtracted, which is 0. And then outside, we have k, and in this case, 0 as well. So our starting point, which is our hk, where we start plotting our points, is going to be 0, 0. Okay, so I started my graph here at 0, 0. The a value is my slope, so I went up 1 over 1, up 1 over 1, up 1 over 1, and kept going. And that's how I built my graph. Now, we are inclined to go down and keep building this way, but we don't. We actually just mirror across on the other side, so we continue to make the V. Or you just mirror across on our points. Alright? Domain and range is always based off domain being all real numbers. Your range will always be based on your K value, and since my A is positive and this graph is facing upward, greater than or equal to. So we're going to do that again with the next graph. And so here we have the parent graph in here, and we're going to just label things out. So our A value is this first one, which is 2. Our H value is being added or subtracted to X. You see a plus 3, so it's actually a minus 3 because it's opposite. And then our K value is on the outside, and it's exactly what you see. So my starting point is my HK. So that's the point that I'm going to plot first. Okay. So with that plotting of that point, what I'm going to do is I'm going to zoom out here. There we go. And then zoom in a little bit differently. There we go. So I'm going to take this first point here, and then I'm going to plot it. This is my parent graph, so I'm going to move 3 to the left, 1, 2, 3, and down 2. Okay? So I shifted that point, and then what I'm going to do is I'm going to use the slope of 2, which is over 1, and that's my dilation. So I'm going to stretch it up 2 and move it over 1. Stretch up 2, move over 1. And I'm going to keep doing that all the way through the graph on both sides. So I can't keep going down because I won't make a V, so I got to mirror onto the other side. Okay? So what I've done is I've taken this graph and I've shifted it to be a little bit taller and compressed. So I'm going to take my pen, draw a line, try not to get the curve of my calculator. Oops. And so that's my new graph. So my domain, once again, is all real numbers. Your range is based on this K value, so y and -2, and my values are moving upward, so greater than or equal to. Also, my A value is positive, so that would also be that. So my next video, or for my next graph, I'm going to identify, I'm not going to color code, I'm just going to write them out. So A is 1/2. H, you see a -6 is going to be a +6. And then K, there's no number being added or subtracted out here, so that's just going to be 0. So my starting point is going to be 6, 0. Domain is going to be all real numbers. Range is going to be y and 0. A is positive, so this is going to be greater than or equal to. And then what I'm going to do is I'm going to go to my start point, so 6, 0. So I'm going to add 0 and I'm going to go over 6. 1, 2, 3, 4, 5, 6, 0. And then my slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2. And I'm going to do that to both sides. There we go. Last but not least, I got this one here. So A is -1/2. H is 0 because there's nothing being added or subtracted in the absolute value bars. And K is +3. So my start point is 0, 3. I'm going to go 0 and then up 3. My slope is -1, so I'm going to go down 1 over 2. And then I'm going to connect my lines. Domain is all real numbers. Range is y in 3. Because my a value is negative and my graph is facing down, it's going to be less than or equal to 3. So with that, we're going to jump over to inequalities, which is on the back side of the sheet. So we're going to graph absolute value inequalities. Remember that inequalities are not equal to, so if less than or greater than, it's dashed lines with open points. Equal to are solid with closed points. And we're just going to do the same thing, but then we got some shading. So on this first graph, A is 1, H is 0, K is negative 2, and that comes from the value in front. What is being added or subtracted from X, which is opposite of what you see, and then exactly what you see, what is being added or subtracted outside the absolute value. So my start point is 0, negative 2. And we don't find domain and range on inequalities. So I'm just going to go to 0, negative 2. So 0, negative 2. And I'm going to graph my graph, which is 1. Now these are supposed to be open circles. My first graph I leave closed because I plot the points so I know where I'm at. And then I'm going to go up 1, over 1. And then I'm going to mirror across to get that V shape. Because if I put a negative number in, I would get a positive result, so I got to keep building the same way. And then once again, because it is a inequality, you dash it out. And then domain and range we don't worry about. Okay, it's an inequality. What we're going to do is we're going to test the point 0, 0. And so when I test 0, 0, I'm testing to see which region is going to make the statement true. So I take 0, 0 and I plug it in. So 0 is greater than the absolute value of 0 minus 2. I'm going to test this out. 0 is greater than the absolute value of 0, which minus 2. 0 is greater than negative 2. That is true. This worked. So I'm going to shade up here. So on this next graph, what we have is an A value of 4, an H value, which is opposite what we see, once again, minusing 1 from X is 1, and a K value of 2. So my start point is going to be 1, 2. So I'm going to go to 1 and up 2. It is going to be open circles, and my slope is 4, so I'm going to go up 4, 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, and then I'm going to do the same thing on the other side. So up 4 over 1, and I'm going to dash it as best I can. Now, it says I want all the y's less than, so I should know I'm going to shade down here, but I am going to check a point just in case I graphed wrong. So I'm going to take 0 is less than 4, absolute value 0 minus 1, absolute value plus 2. So 0 is less than 4, absolute value of negative 1 plus 2. 0 is less than 4 times 1, absolute value of negative 1 is 1, plus 2. 0 is less than 6, which is true. So since this is a true answer, everything out here is going to get shaded. Okay. So the last one that we got is this graph right here, which gives me some different values. A is negative 1/2. H I have a plus 2, so it's going to be a minus 2. My k value is going to be a negative 3. So I have negative 2 comma negative 3. So I'm going to go to negative 2, down 3, put my dot. This is equal to, so all my dots are going to be a solid dot after this. So I'm going to go down 1 over 2. And then to the other side. Solid graph because it includes, because it's equal to. And then I could understand I want all the y's less than this point, but I am still going to test in case I graphed wrong. 0 is less than or equal to negative 1/2, absolute value of 0 plus 2, absolute value minus 3. 0 is less than or equal to negative 1/2, absolute value of 2, minus 3. 0 is less than negative 1/2 times the absolute value of 2 is 2, minus 3. 0 is less than negative 1 minus 3. And that gives me 0 is less than negative 4, which is not true. Since that is not true, this is not true, so I don't shade this region. I shade the region that is down below. Also, it says I want all my y's less than this point are down below, but I always double check in case I graph wrong. That gives you homework 9 and homework 10, the 2 graphing pages.